IP T112 Basic Theory. When a path goes from node A1 to node B3 in Figure 1, and the passing nodes are counted as shown in Figure 2, it is found that there are three shortest paths with the minimum number of passing nodes. Question: how many shortest paths are available there to go from node A1 to node D4 via node B3? The number in the parenthesis below a node represents the number of shortest paths from A1 to that node. So for example, from A1 to B1, there is only one shortest path. And for example, A1 to B2, there are two shortest paths. A6, B12, C9, D2. Let's look at the answer explanation. To find the number of shortest paths from A1 to D4, we can find the product of shortest paths from A1 to B3 and then B3 to D4. So I have drawn the diagram of Figure 2 and Figure 1 in this slide as well, so that it is easier to talk about the answer. So from A1 to B3, there are three shortest paths. Well, first of all, you need to really look at Figure 2. So, for example, from A1 to C2, there is three shortest paths. So A1 to C2, it says 3, so there are three shortest paths. Now, if we look at this diagram, Figure 1, A1 to C2 is talking about this rectangle over here. I am marking it in yellow. So this rectangle consists of two paths and one on the other side. And if we look at A1 to B3, the size of the rectangle is the same. So one side consists of two paths and the other side consists of one path. So that means from going from A1 to C2 is the same as going from A1 to B3. Okay, so the vertex has just flipped. So imagine flipping this yellow rectangle to this side. So A1 to B3 and A1 to C2 is the same distance. So from A1 to B3, so A1 to B3, there are three shortest paths. So three shortest paths. That is from going A1 to C2. So we're seeing A1 to B3. And these are three shortest paths. A1, B1, and via B2 and B3. And A1, A2, and then A3 to B3. And A1, A2, and then B2 to B3. Similarly, from B3 to D4, so B3 to D4, we're looking at, actually let's mark this in other color. So B3 to D4, we're looking at B3 to D4. So again, this rectangle has two paths on one side and one on the other side. So the size of the rectangle is the same as going from A1 to C2 again. So there are three shortest paths available. So from B3 to D4, there are three shortest paths available. Three shortest paths are B3, B4, C4, then D4, B3, C3, C4, then D4, B3, C3, D3, and then D4. So for each path from A1 to B3, there are three possible shortest paths from B3 to D4. So the number of shortest paths is 3 times 3, which is 9. So the answer is C, 9.